Okay, so let's solve the following matrix equation for A, B, C, and D. So two matrices are equal if they have the same number of rows and columns. So we have that, so that's a good start. And if they're equal element-wise, okay? So that means that A minus B equals to 8, B plus C equals to 1, 3D plus C equals to 7, and 2A minus 4D equals to 6. Okay, so that's our goal. So this is basically a system of equations, right? So what we want is A minus B equals to 8, B plus C equals to 1, 3D plus C equals to 7, and 2A minus 4D equals to 6. So this is a system of equations, and we have four variables A, B, C, and D. And actually, if we think about this, this is A minus B plus 0 times C plus 0 times D. 0 times C plus 0 times D equals to 8. And the second equation with the B plus C is actually, we're comparing to 1, and it's actually 0 times A plus 1 times B plus 1 times C plus 0 times D equals to 1, and so on, right? We have a 7 over here. Let's put the 3D at the end with a plus sign, and then we have 1C, and then we have 0A, 0 A's plus 0 B's, and finally, the last equation, let's rewrite as follows. So we have 0B and 0C in the center. 0B plus 0C. And let's use Gaussian elimination. So use Gaussian elimination to solve the system of linear equations. So let's look at the coefficient matrix. So we have the coefficient of A over here is 1, of B is -1, of C is 0, and 0. And we put a little bar over here to separate between this part and these numbers, the 8, 1, 7, and 6. And then we have over here 0, 0, 2, 1, 0, 0. So this is a fairly simple system. 1, 1, 0, and 0, 3, -4. And now I want a 1 over here, and we already have that, so that's good. I want these to be zeros, and only the 2 is getting in the way. So let's take care of that. So I'm going to do R4 becomes R4 minus 2R1. Let's just make that a little bit clearer. Now we only changed the fourth row. That means I can copy everything but the fourth row. And in the fourth row, we chose the operation so that there will be a 0 over here. And for the rest of these, we just have to be a little bit careful, right? So we're going to have, say over here, we're going to have 0 minus 2 times -1, which is 2. So we're going to have a 2 over here. We're going to have a 0 over here because we just have zeros here and here. And we're going to have a -4. And finally, in the last column, because we have to apply the operation also to the last column, this line doesn't really matter. So we should have over here 6 minus 2 times 8, which is 6 minus 16, which is negative 10, if I'm not mistaken. And yeah, that looks correct. So negative 10. And now we need a 1 over here, and we have that. And now I'm going to use this 1 to get rid of the 2, and I'll also get rid of the negative 1 above. So we'll reach reduced row echelon form in this manner. Great. So now let's get rid of both of these. So R4 becomes R4 minus 2 R2, and R1 becomes R1 plus R2. Let's just make this a little bit smaller. Great. So let's see, we've changed row 1 and 4. So that means we can duplicate 2 and 3. Well, I'm going to first duplicate everything. And now we're changing row 1 and we're changing row 4. Okay, and we chose our operations so that there will be zeros over here. And now let's go through this part carefully. So it's R4, so 0, minus 2 times R1, minus 2 times R2. So that's negative 2. It's good to check ourselves. And over here we'll get negative 4 minus 2 times R2, 0. So just negative 4. And over here we're going to get R4, so that's negative 10, minus 2 times R2. What is R2? 1. So that's negative 12. Okay, and this is a little bit tedious, but I'm showing the work. And then let's go back up to row number 1. So for row number 1, we have R1 becomes R1 plus R2. So that gives us a 1 over here, a 0, and a 9. And now I'm going to just show you the end result, or maybe we'll continue just a little bit more. We need a 1 over here, and we have it. So now we'll use this 1 to eliminate these. And that's how we'll continue. So let me just show you what the final result is, because this is getting, a little bit tedious. Okay, so if we continue this, I checked, that will eventually get the following. So the reduced row echelon form is as follows. So that means that A equals to 5, B equals to negative 3, C equals to 4, and D equals to 1. And obviously we should check our result, right, if it's actually correct, because it's quite easy to have a typo. So let's just recall what our original problem was. So this was our original problem. So let's check if it's correct, right? And it might not be, it's really easy to make a mistake. So A minus B is 5 minus negative 3, and this is an 8. Okay, and we have an 8 over here, so that's already good. B plus C, that's negative 3 plus 4. That's a 1, and that's this, so that's good. And 3D plus C, so 3 times 1 plus 4. That's a 7. That's a 7. We have a 7 here. And finally, 2 times A plus 4 times D. So this is 10 plus... Wait, do I have a mistake at this point? Oh, you see, it's a negative over here. So, yeah, negative. So 10 minus 4 is 6, and the solution is correct. So we're good. So have an amazing day, happy linear algebra, and see you next time.